Hello friends, welcome to EPG Pathshala. I am Dr. Shibu Mani, Assistant Professor, Jamshedji Tata School for Disaster Studies at Tata Institute of Social Sciences, Mumbai. Today we will discuss about the disaster management module, which is part of the course Fields of Practice. Disaster management, I will articulate the objectives first. It introduces the key concepts so you will understand the risk. Understanding risk is our primary objective. And to gain clear understanding of a spectrum of hazards and vulnerabilities which falls under diverse categories. And the third one, how important it is for you to gain knowledge on disaster management. And finally, in a practical sense, I would like to create a risk consciousness among you so that you can be part of developing a culture of safety and maintenance wherever you are. Look at this quote. Practically none of us makes dramatic discoveries, but we are helping to advance understanding, and this constitutes the core of what I have seen as my calling in neuroscience by Linda Seger. This is applicable to you as well. You may not make any discoveries, any dramatic discovery, but you will be definitely contributing to the knowledge of disaster management by learning this module. There is a question prevails. Which is more important, theory or practice? Generally, in my experience, I heard the practice that is which we require more. From the general audience, generally I'm saying. But one of my professors said when I was in my post-graduation saying, whether do you like theory or practice? We also at that time unanimously said practice. But the professor said, whether you like it or not, agree it or not, without theory there is no practice. It will be asking like which blade in a pair of scissors is more important. Isn't it both the blades are equally important? So we will be introducing theories also, but at the same time we will expose you some practical applications also. In this process, you need to grasp the description, taxonomy and explanation. So this is the general trend we use in academics. If you are not good at description, you may not be able to classify something which you are interested. If you are not able to classify, you will not be able to explain it. So be on a note. So this figure shows two planes where the academics, whether it is physics, or whether chemistry, whether it is social sciences, or whether it is any branch of social sciences, it interfaces with the government and industries and society. So this is not inseparable. So we cannot work in silos. So we need to move on with a convergence. Look at this slide. It's a very interesting figure, but it looks much simpler. But we are trying to explain the Earth system. Earth sphere has 4 spheres in a system approach if you look into it. It's not simple, it is complex. We have the air, which is atmosphere. We have the water, which is hydrosphere. We have the land, which is the geosphere. And we have the life, which is the biosphere. So there is a lot of interactions between these spheres happens. Now look at this slide. This is from Interpanel for Climate Change. It's a wonderful slide. You need to study this slide very carefully. I will be explaining at an introductory level, but you can do an exercise. You can do a half page right upon this slide. Look at this interaction, Earth systems, and now I introduce human systems. So number of things goes on. You can see words like mitigation, adaptation, and governance, technology. These are all comes under the human systems, but certain things overlap also. Look at this equation. This is known as the Anthropocene equations, came very recently. The change in Earth system. Earlier it was thought that the Earth system, we can make the changes in Earth system only if there is astronomical or geophysical or internal stresses are there. That's why the rate of change in Earth system is considered as function of AGI. You can see the abbreviations there. what it stands for. But this was the case. Now whether human actions can change the earth system, make an impact on earth system, that is why you have seen on the other side. Now in the last 40 years, it is more of function of human action. F is a function of the d by dt is a function of h. Now I will take you to a real case which happened in India. Look at this photo. This is a satellite image of India. It looks very green. In 2013, you might be knowing that you all might have heard of the Uttarakhand disaster. What happened? Two branches of monsoon came at a time and it falls over Uttarakhand, Himachal and some other state also. What's the reason? Why such incident happened? This is the drainage basin of Bhagirthi and Alaknanda, where you can see different districts falls in within this drainage basin. All the sectors, Pithoragarh, Badri, Kedar, Gangotri and Yamunotri, all the sectors were affected. Of course, the impacts were differential, but it is all these were impacted. The press release of June 20th of the IMD, Indian Meteorological Department, noted Northwest India became the zone of an unusual confluence of the two branches of the monsoon, the Arabian Sea branch and the Bay of Bengal branch. The geology and orography of the Himalayan regions of Uttarakhand and Himachal Pradesh resulted in unprecedented impact in these two states. While the IMD had issued warnings of widespread severe rainfall in the region soon after the observation of the advancing monsoon systems, the scale of impact could not be predicted. So that is what the crux is. Now you see the next slide. How much of the destruction in this event was actually man-made is a moot question. Besides the challenges of disaster management on such a massive scale, the Uttarakhand floods have also thrown up a lot of scientific challenges in the detailed understanding of monsoon dynamics, as well as in the geophysical process of landslides and large-scale debris flow and the heavy damage they can inflict on life, property and ecology. Look at this figure. This is from Google Earth. You can also practice this. You have to explore the Google Earth and make use of it to move ahead in disaster management. This is one tool which you can go ahead. The first one shows the glacial terrain, and the second one is a photograph where you can see where the Kedar temple is located. These photographs clearly says go through this. See, there is a Chorabari lake, it is located. These are all glacial or moraine terrain. Now, whether a Chorabari lake, when it gets bursted, such a volume of water will come out. So these are the questions. Where did all the waters came in? Is it through rainfall? Is it through a glacial lake bursting out? Or is it something else? These were the questions in front of the scientist. So look at this, in a typical glacial front, you can have room-sized boulders aligning up. So when the glaciers start melting, due to some reasons, this falls down. So the huge blocks comes down. So this could be, there are many reasons. Snow melt also could be one. So the heavy rainfall has caused the melting of ice. So the vertical melting or also the horizontal retreat happened. So the boulders also have come down. So the water also flown down. So this is an example where after the disaster we went to a village in Uttarkashi, Dinsari village. This is a close-up image where you can see the bridges. I have marked it in a red color that the agriculture fields and also the settlements around a white circle, and all these settlements have actually been carved away by Mandakini river. Mandakini is actually a slow moving river. It has not came up to even 10 or 15 feet, but this time it was 75-80 feet above the bed level. So here this is what the number of landslides happen. Hundreds and hundreds of landslide happened along the Mandakini basin. I am concentrating on Mandakini. You look at this river. So a lot of toe cutting is happening in the clockwise. If you in the extreme left up, you see the river is meandering. The river was not wider, but it is carved away all agriculture fields, and also on the right, clockwise, if you move to the right, you can see the bed also, the river bed also has come up because lot of debris, lot of muck has come because of the flood, and also maybe because of the reservoir, the dam building activities. And here it is, you can see our students have gone for the rapid assessment. This is a clear example that you can also involve in assessments after a disaster. So these are all examples of damages to houses. And here there is a special story to it. We were moving along a road. You can see a small baby, grandfather, grandmother, and mother. So actually this lady has delivered this baby 2 days back. She has, from her village, she has got a chopper, which is shown on a helicopter, small helicopter, which is shown on the right side. She got the facility of going from a chopper to the hospital in Dehradun, but on the way, she did not have that facility. So she had to walk after the delivery, after she delivering the baby, after 2 days, she had to walk along 20 kilometers, 25 kilometers to reach the village. So this, what it indicates, you know, the years of development has now been hampered. It has been destroyed. Seemingly that it will take years to rebuild it back. That is the connection between the disaster management and development. And here we need actually coordination, conciliation, communication, and cooperation. That is why the disaster management means. Disaster management is not just a relief distribution. It cut across many facets. So towards which we need to understand terminologies, contexts, perspectives, and also classifications. Also it is important to know the modern historical roots. So before understanding the terminologies, there are database where you will have a good picture of classifications. EMDAT is one thing which you can explore in the web, in the internet. And virtual globes like Google Earth and Bhuvan. Bhuvan is an Indian version. You know, India has put all facilities with many services. It's like Google Earth. And Google Earth is a wonderful platform. It's free and you should explore it more and more. The disaster management, I am just now introducing the disaster management to understand the relationship between hazards and disaster. This is important at an initial stage, and also to understand different perspectives and contexts by which the terms are defined. You see, look at the hazards, which constitutes like floods, tornadoes, landslides, earthquakes, cyclones, and hurricanes. When the hazard meet with vulnerability conditions, which are rapid urbanization, structures built with the poor materials and techniques, increased poverty, rapid population growth, when they meet together, this is risk. When the risk is realized, it becomes disaster. So this is a good triangle and a circle overlapping, which you can easily understand what a risk is. Risk is a function of hazard, vulnerability, and exposure. And you see if you reduce the hazard, definitely the risk will reduce. If you reduce the exposure, it will reduce the risk. If you reduce the vulnerability, it will reduce the risk. But the point is, as a social science students, you may have to concentrate more on reducing the vulnerability, to finding pathways for reducing vulnerability so that the risk is reduced. There are almost as many definitions of hazard, vulnerability, risk, and disaster as there are experts, and naturally each expert has a preferred definition. This may yield to some confusion, but this module will help you to sort out that confusion. Expert knowledge and popular knowledge are also important. There should be a blend of it. Now let us get into in the dissection of disasters. How can we understand the crisis or the disaster better? So we need to go for the spatial analysis where it is location and extension. So your spatial thinking should get enlarged. See, these days GPS is available with mobile phones. You can utilize, there are many applications which shows the interactive GIS, which is Geographical Information System. Use all these things to increase your spatial thinking. Spatial analysis is an essential component, which I said Google Earth or Bhuvan could be utilized if you are not part of any university or special project. You can do it from home. And temporal analysis, this is based on time, frequency, duration, probability of occurrence, and trends. Dimension analysis, strength, scope, intensity, scale, and magnitude. All these things we require it for defining or dissecting a hazard, to understand the characteristics of a disaster. But the challenge is to arrive on definitions from interdisciplinary perspective, for which the general acceptance level from all who deal with extreme event is expected to be high. Some people use these terms interchangeably, like hazard and disaster, some people use interchangeably. However, in the hazard science literature, each term has a precise and distinct meaning. There is no worry, you can go to United Nations Office of Disaster Risk Reduction, UNISDR, they are keeping a track of definitions. So please refer to this site to get all definitions in one place. We study hazards because they are interesting and important, but also because we hope to reduce damages caused by extreme natural events as far as possible. Look at this overlaps. So the hazards and disaster, these are two different things. Hazards leads to disasters. But in academics, hazard research and disaster research overlap, that you can see from this slide. And do you an exercise. Give yes or no to these questions. Whether floods are required, whether earthquakes are required. You can add this list, you can expand this list and try to plot. You look at this graph. I tried this exercise for a group of students who have not undergone any training in disaster management. You see the differences. Some people say that flood should occur. Some people say, a group of students says that they should not occur. So civil unrest, it should occur, it should not occur. So this through another aspect in disaster management, the perception. To understand this perception, I brought a poem which is very interesting. I will read only a few lines. You can spend time looking at it. Floods in Budosi, western Zambia. Let flood time in Budosi, there is the floodplain clothed in the water garment. So towards the end you can say, and when we ourselves see them, we are inflated with happiness. Our hearts become lighter. They welcome the floods. They know that it comes every year. So it will be evident from the excerpt from the poem Floods in Budosi that floods are expected. And what is considered a hazard in one society may not be considered as such in another. So risk perception is important. In natural science, social sciences, engineering, management sciences and communities, the experts coming from these science fields and the people at the community level have different perceptions. So we need to have an understanding about this perception. As social science students, you may have the skill to explore this. What is the perception of floods in the administration? What is the perception at the community level? Why certain schemes are not working? And why certain schemes are implemented? So here comes the participatory nature. If you include the community at different levels before decision making, and it will be good. The expert and the popular knowledge gets blent and the schemes what we are proposing and get into a successful mode. The classification of hazards are generally useful for providing frameworks to identify similarities among and making generalization about hazardous events. Typologies also promote sound management practice. In reality, hazards result from interrelated causes, and classifying a hazard to a single class is challenging. Still, classification is an important aspect. We need to move forward. So, for your understanding, the classifications of hazards, there are 6 categories I have put forth. Maybe there may be something more, but this is enough for you to start with. Classification based on causes. This is actually the primary classification used in many fields, and which itself has some subsets, which is, I have put it as ABCD. And classification based on intensity and spread, classification based on behavioral aspect, classification based on the speed of occurrence, classification based on direct involvement of humans, and certain agencies which I have already mentioned, EMDAT, they have put their own classification. So let us take the classification based on the origin or cause: natural hazard, social hazards, biological hazards, technological hazards, and chronic hazards. Let us go into each. Natural hazards, what are those? These are all mostly natural phenomena which man does not have a control. For example, geological, which is earthquakes; meteorological, tropical cyclones, which man does not have a direct control over it; hydrologic. And what is social hazard? This will be a very interesting thing for you. Intentional hazard. Some hazards such as famine, warfare, acts of terrorism, and civil disorders originate in social systems caused or exacerbated by human action. Some social hazards such as civil or armed conflicts are often termed complex emergencies or complex humanitarian emergencies. So you can think of which are the hazards you can classify into the social hazards. Biological hazards, for example, the epidemics, they are often divided into two categories: pathogens and toxins. One is bacteriological, one is chemical. And the technological hazards, they originate from the interaction of society, technology, and natural systems. Example, explosion, releases of toxic materials, and oil spills. Events of this group are also termed as non-intentional hazards. You might be remembering earlier slide we have seen intentional hazard, that is sociological. And technological hazard, there is a further subdivision: industrial hazards, transportation hazard, structural collapse hazards. For example, many buildings collapse. So we can put those into the structural collapse hazards. Chronic hazards. These hazards arise from long-term events such as continuous discharge and occupational exposure. They do not stem from one event but arise from continual or long-term conditions or problems. Example, pollution. Such hazards can lead to health or environmental effect. Chronic hazards are the type that will be most affected by changes in the global environment. Technological and chronic hazards may be called human-induced hazards because a large part of responsibility lies with the human being. The other hazards classification based on the origin, the hazards primarily originating from the atmosphere, endogenous or exogenous origin. These are very simplified categorization based on the origin. And the last one based on the origin is natural, biotic, socio or pseudo-natural, man-made, technological, social, conflict, including war, civil strife, and violence. So so far we have discussed the classification based on origin. Now here comes the classification based on intensity and spread, classification based on behavioral aspect, classification based on speed of occurrence. For example, the speed, if the speed of onset, abrupt. For an earthquake and tornadoes, it is very quick. It lasts for a few seconds. Slow onset, drought and desertification. And classification based on the direct involvement of humans. And the last one is, again I'm repeating, that EMDAT or CRED classification, where they again classified because it is a database what hazard should be to be qualified as certain categories. They have classified it into natural, technological, and etc. I have given some reading. The Bimal Kanti Paul's book, primarily from which I have taken much of the content for this module. And also you can, as an activity, I have suggested two. One is of CRED, go to the website of EMDAT, and also you should start exploring the Google Earth. Now let us come to we have done with the classifications. Now let us look into the physical dimensions. What are that? Magnitude is one among them, and you can read it as you get time. For example, let us take an example of earthquake. Earthquake is measured, the magnitude is measured in a Richter scale. The intensity is actually on a Mercalli scale. So for everything you may not be able to measure. For example, the social hazards, you may not be able to so easily measure the power of force. But most of the natural hazards, floods, earthquakes, cyclone, where the scientists have established magnitude and intensity. The frequency, it describes how often an event of a given magnitude or intensity occurs over a given period of time. This can be expressed in qualitative terms such as frequent or rare, or a more quantity term such as recurrence interval, return period. For example, Uttarakhand disaster, the floods, is considered to be 1 in 80 years or 1 in 100 years. It is a return period. It does not mean it will happen only after 80 years, but there is a probability of occurring that event in 1 year is 1 in 80 or 1 in 100. So here comes a major aspect, the magnitude frequency concept. The magnitude, the more the magnitude, the event, the less the frequency. That is the general understanding. But these days, this trend is changing. The more magnitudes, the frequency is getting increasing. That is why this discipline of disaster management getting momentum. Seasonality is another physical dimension. All disasters may not happen throughout. Any time it cannot happen. For example, the cyclones in India happens at certain period of time. And earthquakes, for example, or volcanoes, there is no seasonality. Spatial extent refers to the area over which a hazard event occurs. It is usually associated with the amount of damage incurred and frequently with the number of deaths. Some hazards like tornado may have a small spatial extent. Others, such as drought, affect large geographical regions. Spatial distribution refers to the distribution of hazards over the space in which they can occur. Speed, rate of onset. This we have already discussed in the classification, but this is an aspect of physical dimension. Refers to the speed at which an extreme event transforms from its first appearance to peak strength, the length of time. Diurnal factor. In a day, at different time period, even in a day, things can change drastically. For example, the time of the day refers to occurrence of an event at a specific time or day or night. The potential degree of damage and deaths from an event in a major city is likely to be very high if it occurs during rush hours when people are commuting. Another example, the landslides, if it happens in the night time when people are sleeping, there are chances more people are vulnerable to death. But where happened in the morning, in the daytime, people may be going for work and children may be going for school. So there may not be many people residing at the house. This time the destruction will be only to the property. So again, I have given the readings. This is available on the internet. You can freely download and read. The hazard identification methods can either be perspective or creative. Most of the time, the combination of methods should be used to get a clear picture. The suggestions are brainstorming. You can research on disaster history, reviews of existing plans. For example, many of the Indian states, almost all states, it's mandatory to prepare disaster management plans. Districts, it is mandatory to prepare plans. If it is available, you should read one and see what are the things what we discussed are incorporated in and what have not been included, and that will help you. Let us go into the concept of vulnerability. Earlier we have seen risk is a function of hazard, vulnerability and exposure. So we have covered substantially on hazard part, classification, magnitude, and here comes vulnerability. This concept you might be more interested as social science students. Hazards are often defined in the context of vulnerability, which is a complex outcome of many factors such as affluence, education, gender, demography, technology, preparedness. A combination of different factors such as socio-economic conditions, geographic locations, political influences, demographic characteristics shapes the different levels of vulnerability of different group of people. Look at the type of vulnerabilities. Physical vulnerability, hazard-prone locations. Technical vulnerability, structures and infrastructures, for example, houses, roads, bridges, irrigation channels, which are unable to withstand and resist hazard events. Economic vulnerability, insufficient assets and reserves to withstand loss. And social vulnerability, because it is inhibited in the social structures. There could be number of things, old people, illiteracy, poverty, all these things are also contributing. So if it merge with hazards, there is a potential chances for disasters. Vulnerability as a concept is useful to assess disasters and has provided a helpful guide in the formulation of approaches and policies towards preparedness and relief provision. Vulnerability is associated with a lack of power. Groups marginalized through poverty, illiteracy, race, ethnicity, or immigration, and minority status. Here is one model which is known as pressure and release model. This is available with your module note. Root causes, dynamic pressures, and unsafe condition. This is the progression of vulnerability. So the extreme left, you can see the power, the limited access to power, and then lack of infrastructures, etc. And then it lead to different unsafe conditions. When these vulnerability meet with hazards such as earthquakes or high winds, then it can eventually turn out into a disaster. Let us look into the modern historical development in disaster management. The objective is to know the progress at global level on the aspect of disaster management. If you look, we don't have to go back many years before Christ or before Christian era. The International Decade for Natural Disaster Reduction, which happened in 1987, the Yokohama Strategy in 1994, Hugo Framework for Action 2005, Sendai Framework came in 2015. These are all about disaster management. On the other hand, on the development side, Millennium Development Goals came in 2000. And 2015 came up Sustainability Development Goals. So there is a link between disaster management progress and also the development management. This is what earlier we have discussed, how the development is connected to disasters, how we should be including the aspects of disaster management when we do the development. What should be the modalities in development planning? So the questions to ponder is, bringing all these things together, there's a certain larger questions. Why is it that people live where they live? You may be wondering, for example, the Kosi floodplain. Certain people have no other options except to reside on very unsafe conditions and also in a very unsafe house structures, where poverty may be one reason. They may not have the money to buy other lands. So number of things. Whereas you look at the California, where everybody knows it's an earthquake prone area, but very many people goes into that. Japan is highly prone to earthquakes, but people flourish over there. People build buildings according to the standards and according to the codes. So these questions, what I am putting forth, should lead to action, to create risk consciousness, assess, prioritize, and communicate and mitigate. All what we have seen is now, we have seen the hazards, classification and its physical dimensions, and also we've seen vulnerability. One aspect we didn't see is exposure. Exposure is simple. Elements of risk such as population or houses or roads, infrastructures which exposed to. Vulnerability we have seen, which is actually coming from socio-political, cultural, and from economic context. And our idea is to understand risk so that an assessment is there, and then you should be able to prioritize and you should be able to communicate to the people who are not aware of this. And we should be able to take action to mitigate it. So in such a way, that is way we can have a risk conscious society. For example, safety. Number of terms you can add to the safety. For example, the school safety, electrical safety, sports safety, crowd safety. So number of things you can contribute to it, either as an act, as a stakeholder, you can behave as as a civic, a responsible citizen, stewardship is an important aspect which you should consider. So the result of creating a risk conscious society is actually, so then we can be known or called as resilient society or resilient community. Thank you very much. I hope this will motivate you to contribute to the risk consciousness, your own consciousness, and also to take actions, and also to help others to come into this risk consciousness. So as a nation, we can be called a resilient nation as far as the disasters and development are concerned. Thank you very much for listening.